Hello. Hey guys, my name's Connie. I'm gonna actually step so I don't block this. Founder of Olympix.
Hey everybody, I'm Zach, the founding engineer at Olympix.
Maybe we should switch actually. Or
Oh yeah. I can click it.
Okay, cool.
Yeah.
So today we're gonna take you through, hello, Web3 security best practices. Okay, so this is the sad reality of today. 16 billion plus has been exploited from exploits to date, and that number continues to go up. And why? I actually like to switch with you. Yeah, just have a little control over the privacy. And why does the number keep going up? Okay, what's going on here? Well, people are treating the Web3 attack surface like the Web2 attack surface, and that's not the case. It's exponentially larger. So what do I mean by that? There's three. This is a different privacy. Oh, okay. There's three things that really stand out to us. So the first thing is the immutable nature of code, right? In Web 2, we live and breathe patch, redeploy, name of the game. In Web 3, changing your source code is a completely other animal. Second reason, okay? The transparent nature. Web 2, we have security via obscurity. Web 2, we have the luxury of a firewall. Web 3, everything is extractable at a source or bytecode level. So you don't have those protections in place. And the third, which of course, because it's the wrong prezi, which always happens, third reason is the direct access to liquidity. So in Web 2, you're a bad actor. All right, I'm going to get into your system, I'm going to steal your data, I'm going to sell it on the dark web, and then I'll have crypto, right? Web 3, here's how it works. Hey, Zach, you have your protocol?
I do.
Okay, Zach protocol, right? Line 42. Oh, 80 million in liquidity. Let's say you're doing big, right? Okay.
I'm doing really well.
Line 42, reentrancy. I could have that in my wallet in the matter of hours. So this attack surface can be most likened to like aerodynamic security or medical device security, where the stakes are so high. So what does that mean? It means that the shift, and the reason this is happening is because people aren't treating it as such. The development methodologies, the tooling that needs to be used needs to be a lot more robust. We can't just be relying on a manual audit. And this is pre-deployment, post-deployment. The audit's just one piece of it. So how do we do that? We could sit and we could say, this is all auditors' faults, this huge astronomical number. Or we could be realistic and say, hey, even though 90% of audited contracts 90% of exploited contracts are audited, we need to lessen the reliance on audits. And what does that mean? It means owning developer security and actually shifting that responsibility left. Okay. So today what we're going to do is we're going to go through what that looks like in terms of what you need to own internally and what you need to do pre-audit. So this is going to set you up for success. Obviously, as someone who has a protocol, the most important thing to you is if you're dishing out 25K, 50K, let's say you're big and large and it's 500K and you're going for like a trail of bits or something like that, you want to know that that isn't going to get exploited, or your confidence is going to be very high. And when you don't come with the right preparations in place, like 100% test coverage, running your own fuzzing and variant testing, which Zach's going to take us through a live technical demo of what you need to do, you set yourself up for failure. And that's not a good place to be, right? Only hurts the ecosystem. So what does this look like internally? Okay, design decision, so critical. Design for simplicity. You do not need, I know there are edge cases, right? Let's keep that in mind, but you do not need to come up with some crazy new pattern. Oftentimes, there are protocols that are operating and have well-tested, simpler design patterns that you can implement and adopt. That's the beauty of the ecosystem, right? Do that if you can. You don't have to introduce an attack vector. Second, we have no correlation or we don't work. Basically, we just recommend Foundry because we love it. It's a free tool. It's incredible. It really makes the internal development process seamless in terms of testing your contract. The framework's incredible. Zach's going to use it for our live demo. And the second is, of course, you guys already know this, but you need to design an emergency stop mechanism. It sounds obvious, but a lot of teams aren't doing this, and this is critical. And so I'm just going to read the bottom to you because I think it's just like a hammer it in. But the financial nature of crypto really means that every technical flaw is a security risk. It's not like Web 2, like as Zach says, ship things and break fast. What do you say, Zach?
Move fast and break things.
Right, I think Zuckerberg says something like that, right?
Yes.
Yeah, that's not what we can do here. If you move fast and break things, your company's gone. So we don't have that luxury. Okay, so now this gets exhaustive, right? No one likes this, but this is the reality of what you have to own. Okay, 100% test coverage. If you're going for an audit and you have less than 100% line and brand coverage, they're going to look at you, and they're even the top auditor space. They're going to say, we have lower confidence in your audit. You don't want that. Okay, second, fuzz and invariant testing. Very easy to implement. You can go crazy and like add formal verification and learn Certora, go all out, but most teams can't do that. So let's at least own fuzz and invariant testing, which can be made really easy using Foundry. At Olympix, we actually have automated fuzz and invariant testing, as well as automated unit testing. But you don't need us. You can do it on your own if you want. If you want to automate it, you can too. Hack yourself. Okay, so what is the worst case example? What does it look like if your company goes down? Be able to kind of replicate that and try and create that internally. Protocol documentation, again, must have before going to an audit. Keep your inheritance manageable, so minimize the depth and width of the inheritance tree. Well-tested libraries, again, another thing. There are plenty of beautifully tested, battle-proof libraries. You can use those. Most of the time you can. Be really careful what you implement. If it's not in that category, you are introducing a lot of risk. And that affects your company, that affects your users. It's not a joke. Events, known and true, make sure to log. And then last thing is an incident response plan. You need to plan as if you're going to get exploited and know what you're going to do if that's the case. So these are, again, a very exhaustive, annoying list. Olympix does automate a good portion of that, which we'll try not to shill too much because really the point is, hey, here's what you need to do. So we're not going to take you through Olympix tooling today in our technical demo, but we'll show you how to do it. And just keep in mind, if you implement Olympix tooling, it'll split that time in probably like 10% of the time that it would take to do it manually. So with that being said, I'll shift it over to Zach.
What's up? All right, so I'm going to be taking you guys through a little technical demo. And really what I'm going to be talking about is the major differences and the change in responsibility between the typical Web 2 startup and the typical Web 3 startup. So here I have a contract, just kind of like a random use case. I'm not an accountant, but it's a, oh wow, that's pretty blurry. But it's a balance sheet, so you can imagine maybe like an accountant at a company in-house wants to, for some reason, use a decentralized balance sheet. Maybe it's a global company, everybody could have access to it, everybody could see it, and there's some, multiple parties involved. So you can imagine a use case, but basically the point is we have a contract that's supposed to function like a balance sheet. And what we have here on the right side, and this is in Foundry. Foundry is a really awesome testing framework. You basically get to write all your tests in Solidity, which is pretty unique. And you get to represent your tests as contracts as well, which is pretty native feeling, which is very nice. But basically what I have here is kind of the starting point of the where the responsibilities of a Web 2 startup might feel satisfied. So I have, a few tests. I have tests for basically all the happy paths to the user stories. So you can see in my balance sheet contract, I have functions, which are basically user interfaces to add an asset, remove an asset, same thing with liabilities. Maybe calculate the equity. And yeah, these tests basically just go through those user stories and make sure they work. And that's basically it. And you, as a Web 2 startup, you might say, okay, I'm done. Like, it works. Bugs will come up for sure. The users will report them, and then we'll fix them. That's how it's supposed to work. Move fast and break things, as that guy once said. So, I mean, yeah, like, for a lot of startup engineers, this is what it's going to feel like. There's so many great engineers who like move from Web 2 to Web 3, and just this is their experience. And especially if they have great experience working at startups that are not crypto startups, they'll feel pretty satisfied and they'll feel secure. But it's kind of your responsibility if you're like managing or a CEO or something to make sure that this is not where it ends, because you have to go a lot farther than this, particularly before the audit, because you don't want to show up to the audit and this is it. They're going to grill it. You're just going to have to go get more audits afterwards. they're going to come back to you with low confidence. So you don't want that because that's like another 50K or something. So that's not cool. So what is like the first next thing that the crypto startup must do that the Web 2 startup might not need to do? I think, and we think at Olympix, that that's code coverage. So, of course, a lot of Web 2 companies are going to have high and 100% code coverage, but most of the startups probably won't. They'll have the happy paths, and they'll call it a day. So, just an example here. Again, we love Foundry, so we do this in Foundry. Foundry has a really great. Let me put this mic down so I can type with two hands. Nice. So. Okay, so we can see, I'll just hold it again. So we can see that we don't really have full coverage here. And even though we tested all the happy paths, we don't have full coverage, particularly in like the sad paths. So that's where these require statements fail. And you can see the yellow here. That means it's only hitting one of the branches, not both branches of the require. So I have these tests that I commented out, but that, maybe if you're a Web 2 startup, you wouldn't feel the need to make these, but you really should. And when we put these tests in, let's say we spend some more time, we write these tests, we get full coverage now. And we run the tests again. We can see that they're failing, okay? And that's because I have a little bug here. This should not be less than or equal to, it should be strictly less than. Okay, whatever, big deal. But it is a big deal. It's a big deal in crypto, whereas it might not be in Web 2, something like this. Okay, you just fix it, whatever. In crypto, if something like this happens, you read about every hack. It's like the hacker puts the contract in a weird state that you weren't expecting, and that's how they hack you. So you can't really allow for unexpected behavior anywhere. Okay, so now this is the point of this example is basically we fix our code by making sure we have fuller branch coverage. That's basically it. And this is like something that might not be prioritized outside of crypto as much in the startup world. Okay, so first thing, make sure you have the highest test coverage, full coverage, like no excuse not to before you go into an audit. Otherwise, you're really just wasting your money. Okay, what's the next thing? The next thing, and we're going to stick with Foundry here, is the really nice fuzz testing they have in Foundry. So, I mean, now we're starting to get out of the, what I would call like the reasonable world of a Web 2 startup, trying to ship things quickly. You're not going to see much fuzz testing, unless it's like, something about aerodynamics or whatever. Not like, when Instacart was a baby, I'm sure they were not doing this. So fuzz testing. Foundry makes this super nice. You can, just like your unit tests, you can have a contract that just implements fuzz tests. All you have to do is include the string fuzz in the name of your tests. And that's really it. So let me just run this, put the mic down. Actually, let me talk about what the fuzz tests are a little bit more before I run them. So with fuzz tests in Foundry, you can have your test function and then build it with parameters. And then Foundry will just randomize those parameters, and you can have it run a lot of times. You can actually set it in your configuration. And this is cool for a lot of reasons. Number one, it just throws more stuff at your contract. Okay, great. This is kind of an obvious reason. More situations you might not have thought of, randomized values. Another reason is it kind of forces you to use this assume cheat code. And what this assume cheat code does is it forces you to think about the constraints and the limitations of your code. So in this case, I have asset value is less than 100 ether up here. OK, that means that I'm considering the system to have a constraint where this function should not be called with anything greater than that value. OK, that's something that maybe I wouldn't have thought about without this. Something that this really forces me to think about. Another thing is it kind of makes you think of assertions that you might not have thought of otherwise. So in this case, what we're doing, and what really came to my mind when doing fuzz tests for this balance sheet contract, is what if someone in one transaction does a lot of actions at the same time? And that's why we fuzz over here like num assets. So this means this person's like adding multiple in one transaction. OK, great. Like these are like the types of things that will just make your audit cost more if you don't think about them. So just nice to think about. And yeah, so let's see. So I'm going to run it now. OK, and they're failing. Why they're failing? Because when we were thinking about adding multiple at the same time, one thing that came to my mind that I was forced to think about from the fuzz test was the order in the storage. So whereas I might not have thought about the order of the added assets and liabilities, adding one at a time in like a unit test that only considers like one or a specific situation, when you start to fuzz, and you start to fuzz on different stuff, like the number of assets being added, then it starts to make you think about the different things you're fuzzing and the results of them. So in this case, we're checking, is the order preserved? And it's not. OK, so let's fix that. I have the fix down here. And it's fixed. Cool. OK. And not to show too much, but this stuff can get pretty time consuming. So at Olympix, we have AI tools that basically automate this, basically know how to use Foundry really well, which is cool. Basically, all you have to do is kind of like make a skeleton contract. You make a setup function, and then you hit our CLI, and it does all the rest. It just kind of fills it out. So that's like if you're kind of feeling like, wow, this is just too much work, I don't have the time for this, like that's let us know. OK, cool. So that's the fuzzing tool. And the last one that I want to talk about from Foundry is the invariance tool. So this is something really cool. Really, they're both fuzzers, the fuzz and invariant tools, but there's a major difference between them. The fuzz tool is stateless, and the invariant keyword is stateful, but they're both fuzzing. So what that means is that in the fuzz test, let's say it runs it 300 times. You have that in your config. It'll throw the parameters at it, and then wipe everything, start over, throw it again, and do that 300 times. With the invariant testing, there's a few differences. First is that it'll call all the function selectors on your contract, so it'll just spam randomly which function it's calling, as well as the parameters. And it will also preserve the state between the calls. So whereas the fuzz keyword in Foundry will wipe the contract and then do the next call and do that over and over again, the invariant test will preserve the state. So it'll throw something at it, keep that same contract, throw something at it again, keep that same contract, do that 300 times, and see if your invariant is broken. And what that allows for is a really cool, nice, clean syntax that's just an assertion statement. And these assertion statements can get quite crazy, actually. In this case, they're all one line. It's kind of like the intro to Foundry invariant testing. But you can imagine if you want to check for a lot of things, or if you want to check like a whole data structure, then you can have some pretty beefy invariants. But in this case, for this demonstration, some things that I thought of for the balance sheet were just, the owner doesn't change, the total supply doesn't change. These are just kind of like how it was designed. And you can't have negative assets or liabilities. Okay, pretty chill. And what that allows for is it's a few things. Something I really like about it is that besides from, of course, you can write these and then find bugs where they're broken, which is huge, and will save you tons of time and money on your audits. It's also a really good way to communicate with the auditors. It's almost like a coded documentation. It's like these things cannot be broken. Here they are in code. So it really can help the auditors understand your code better and faster, and just less auditing hours means less rounds of audits and less time at each audit. And yeah, so let me do one more thing. It's also really good for introducing new features and refactoring. This is the example I'm going to show you now. Let's say you have a new feature request where you want people to be able to purchase equity in this balance sheet and just mint them like the ERC20. So someone goes along and adds this. That's not cool, because we know that the total supply is not supposed to change here. And that will flag the invariant. That total supply does not change. Okay. And what can we do to fix this? Well, instead, we should have the owner transfer the original, or a piece of the original 100 tokens that were minted, since we know that in this case, the design of the contract is that the total supply is not supposed to change. And yeah, so I mean, again, not to show too much, but we have tools that automate all this with AI. They read your project, you just build the setup function, and it'll fill out the contract for you with all this stuff. Works super well. So I'd recommend giving it a shot. Yeah, thank you for listening. Any questions?
So you mean the AI is helping write all the tasks?
Yeah. So it's so.
Here, take back the mic.
Yes. So from the user perspective, it's like you will build a skeleton test contract, which means you just have the setup function, and that kind of tells the AI how it's being deployed and everything. And then for unit tests, it'll just fill it out until there's sufficient coverage. And for fuzz tests, what we do is we convert pre-existing unit tests into fuzz tests. So we can identify constants in unit tests and fuzz them, which is a really nice experience because it allows the developer to kind of stay in the real world and think of real non-abstract scenarios with hard-coded values, but then the tool will take them, fuzz them, and identify bugs like
And
that.
so the developers using this tool are loving it because it's saving them a lot of time, and they're still hitting this checklist. So instead of going to the audit without these things in place, having lower confidence, having to get another audit after, they're coming to the audit with these things. They're getting it done. They're getting it done in sufficient time. They're getting incredible results. So that's kind of the promise with Olympix. Whereas you can also do it manually. You're just adding on that time. So you're just spending more time on it.
And also, what's your business model?
We could definitely take that offline.
Save you time. Give us money.
Okay, great. Thank you guys. Oh, please.
Thank you. So you're automating all the steps that you just walked through manually.
Yes.
And the promise here is that, so this doesn't replace an auditor. This is.
It is not replacing
the
an auditor. It's
checklist.
supplementing, right? So a lot of teams that we work with are currently getting 2 or 3 audits. And most teams wish they could, right? They wish they could get 2 or 3. Maybe they can't afford it. So instead, they're implementing our tooling and getting 1 instead of 2. Or 2 instead of 3, right? Or, even have some teams working with us and then working with auditors that do pay per vulnerability. So it really depends on your budget and where you are, but no matter what team you are, you need to have this checklist of items. And all we do, we're telling you, like, you do this with or without us. We don't care, but you need to do this, right? That's what the point of this session is, educating you. But then if you want to do it with us, it's going to take you like a tenth of the time. That's basically it.
Can we see the tool?
We can certainly set up a live demo.
Sure. Okay.
Not right now. But yeah, of course. We can connect on Telegram. We can make that happen.
It basically just works as a CLI. You just make some config, you make some setup, and then you get like either a PR or an email.
What? A demo? Do you have a protocol?
Ebisu. They just.
Oh yeah, perfect.
Sweet.
Oh, that was an awesome presentation. I just watched it. Okay, cool. Yeah, we'll definitely get you on. And also, we have a free tool. I want to say this too. It's our give back to the ecosystem. We have a static analyzer, benchmarks best on market. You can get it on VS Code. It's an extension. So start with static analysis. Dip your finger there. That's the first step to becoming a security forward dev. And then you need to implement the next steps. But static analysis is non-invasive. While you're writing code, you're going to get those notifications. If any patterns occur that are introducing potential attack vectors, it'll let you know. Free. Use it.
Yeah, for that tool, just go to the VS Code extension marketplace and type in the name of my shirt, and then you can download it.
And then watch the magic happen. Okay, thank you guys so much.